Good afternoon, everybody. Welcome, and thanks for attending this session. You have options, you have choices, but you chose to be here, so I really appreciate that. I know it's in the middle of the afternoon, it might be challenging. I hope you had a good cup of coffee or tea before this. I'll try to make it interesting. This is one of my favorite conferences, and very happy to be here and to participate this year. The vibe here is so exciting, and we all drinking the same AI Kool-Aid, right? So in this session, I'm going to share my personal and biased perspective on LLMOps, and some of the details here that I will touch on hopefully will resonate with you. By being here, you probably have some sense of what LLMOps is, I hope. But just curious, can I show of hands if you or your team at your current company is building something like LLMOps at your company? All right, about 15%-ish. Okay. So for the rest of you, I'm not sure why you're here, but welcome. All right, it's always fun to generate images nowadays, so easy. So I'm going to start with this. There are two images on here. And they're probably not easy for you to reverse engineer the prompt that was used to generate these images. The one on the left, the prompt that I used was essentially the title of this presentation. So as you can see, it's not doing a very good job of this, of what I wanted. And the second one is the prompt for that was about replacing LLMOps with just MLOps. And it looks like it knows a little bit more about MLOps than LLMOps, which kind of makes sense. All right. How many of you have seen this quote? This has been around like about 8-9 months. It was posted on LinkedIn from Cassie, an ex-chief decision scientist at Google. It was an assessment. It's a fun but quite effective analogy in my perspective. It was an assessment of GenAI and building GenAI in an enterprise about 8 months ago. 8 months in this GenAI era is like years. So the question is it getting easier or not, right? We certainly have a lot more choices than 8 months ago in terms of technologies, options, vendor solutions, and all such. Now, this is where I love to do a quick survey to get a sense of out there, your company. How many, show of hands, if your company has productionalized external-facing GenAI applications? Look at that. That's less than 10%. So this statement is still relatively true based on what I'm seeing. I was going to ask like how many applications have that, 3 or 5, but look at the hands, only a dozen of people had their hand up. So why is it challenging? That's one of the questions. All right, my name is Hien, and I work at DoorDash. I lead the ML platform team there. Before that, I was at Uber and LinkedIn. So in this session, I would like to start with highlighting some of the unique challenges of developing enterprise-scale GenAI applications. And we'll discuss some of the application archetypes, not so much about what they are, but more from the perspective of how do you think about when operationalize them? And then I'll share a few interesting LLM use cases at DoorDash. And finally, share my personal perspective on the LLMOps. All right, is MLOps still relevant, by the way? Right? This is a topic that we talk a lot about in the last, 5, 6, 7 years. It is as if like a forgotten child that once was very, very popular. But if you think about it, the principles behind LLMOps, in my mind, is still very relevant for GenAI applications. For example, automations, right? You want to automate repeated tasks. You want to foster collaboration with all the folks that are involved in building the application. You want to have reproducibility in terms of the way you build application, the very parts of it. And observability. You want to protect the downside, and you want to have a good feedback loop to improve your model performance. With GenAI application, ML observability becomes even more important, in my mind. So we are, in the midst of this we call AI revolution, such an exciting time. And we as humans love new shining tools and capabilities. But sometimes we overlook the problem and the process that the tool was supposed to solve. And in doing so, we might introduce some accidental complexity in this process. And that's not going to be good for your team's long-term productivity. So keep that in mind. So the summary is, while new technology offers new possibilities, the principles for building LLMOps or great products are still timeless. So keep that in mind. All right. You might have seen this graph before in terms of where we are in terms of GenAI. We are somewhere in the middle of this S-curve, depending on who you ask. Could be at the bottom or at the top of the what we call inflection point, where there's tremendous innovation in the capabilities. So keep this in mind while you're building infrastructure, because the rapid pace of changes in terms of, it will continue to improve in terms of speed, performance, cost, techniques, and best practices are emerged and will continue to emerge. So keep that in mind while you're developing your infrastructure. All right, it's kind of funny that we have a new term for ML models that we've been developing for the last 10, 15 years. I don't know who coined it, but it's called classical ML, right? You might have heard that a few times. But now we need to spend more time thinking about working with LLMs. What are some interesting, unique challenges around working with that? So certainly, we have less end-to-end control when working with these because they're not trained by us. And the compute is the new oil, right? GPUs is a must now for working with these LLMs, and GPUs are not cheap. So cost is also becoming a big factor in this new world. And the last part is a pretty big deal, hallucinations and biases. So yeah, these are some of the unique challenges there, working with LLMs. Additionally, we have choices now. Besides working with proprietary LLMs from these frontier model vendors, we have choices in terms of open source models, LLMs. What do you call it? Small model or whatever that is. But working with those have choices actually bring them in-house, fine-tuning them or serving them and such, which is great. But infrastructure that's need to make that happen, there's still going to be a lot of interesting challenges there. This, if you haven't, check out the blog that talks about this. I think it does a great job of summarizing the different dimensions of working with large language application and the challenges from the model quality to performance, computational requirements, especially the inference-related challenges, right? In the old days, we are expecting prediction to happen under, 15, 20 milliseconds. With LMs, good luck with that. But the people that used to work in that world have the same expectation. So you need to have the education and dialogue with those folks to manage the expectations. Interpretability, guess what? That goes out the window because you don't absolutely have no control over that. So what solution, what technology can you use? What safeguard can you think about to help your product teams to manage that, especially for external facing applications? This is an awesome and fun image that I stole from one of the presentations in QCon London. I don't know if the presenter of that presentation is in-house. I know she's here at this conference. But essentially, this is a trend that I've been observing because GPT and other frontier LMs are so accessible right? Just an API away. Most folks would treat that as like a big hammer for all the needs that they have in the company in terms of building applications. It might not be a bad idea to experiment with that, which is okay for experimentation, but you're going to take that to production. That might not be the best options. So I think this picture essentially encourages us to revisit that approach, because it might not be most effective and efficient solution as we move forward. Cost being one of the factors to think about. Although the price of these, frontier models are dropping, but when you're talking about millions of calls, things add up, costs adds up. This is a report from A16Z. I think essentially in an enterprise, right, most of them adopt the technology for internal productivities, which is a great place to start, safe inside your firewalls. But the moment you start thinking about bringing them to user-facing, then you got to think about how to deal with these aspects, hallucinations, biases, especially if you are in a highly sensitive consumer factors. If you're in that space, then there's a lot of things you got to do before you go into production. Have AI governance program and all that good stuff beforehand. Now this, I don't know, your company has this challenge, but some company have this challenge in terms of not having a clear strategy in terms of adopting GenAI. I believe that this has to come from leadership. They have to provide that clarity for you and your team. If they don't, you might want to go and ask for it. Essentially, what it's referring to is where to invest inside your company, right? Which part of the business to invest GenAI in. And within that, which project you want to prioritize, where to start first, second, and third. And also have a sense or an approach around how to fail fast, right? To pull the plug when the experiments don't work out. Because by having that sense of cohesive strategy and roadmap is to ensure there's an efficient allocation of resources within the company. And also the clear framework for prioritization. Now, if you're in a platform team building LLMOps, you definitely want to understand the strategy. You definitely want to understand the prioritization, because you want to cater, you want to work with those teams that are funded for those projects, right? So that's something to think about. All right, so those are some of the interesting challenges there. And now I'm going to go into the second part, which is talking about a different archetype. And again, this is not about describing. I'm sure most of you know what these are. It's more about asking questions to think about when you take these applications to production. So prompt engineering. It's funny. Prompt engineering was a very hot topic, I don't know, about 6-8 months ago. No one talks about it anymore as far as I can tell. But it's a very foundational in terms of a key part of any GenAI application for that matter. Right? So they said prompt engineering is a new programming language, treated like code. So how do you think about versioning these prompts? How do you think about testing them? How do you think about logging the request responses, doing A/B testing? I talked to a few of the teams internally, and guess what? Most of them hard code their prompts right now in the application because it's quick to get going. But if you scale up, you get more team members touching the prompts, or you get your business people influence the prompt, then things are gonna get messy, right? Because if you just change a few words, that's gonna, you might get a totally separate response from the LM. So these are very important part of thinking about the principles we talk about, the automation, the reproducibility, right? RAG-based application, right? The next level up. Now you have additional components to your application, meaning the model for generating embeddings. You have a vector store database. I'm sure you probably have done a ton of prototypes with RAG application. Everything's in memory, everything works just fine and dandy. Awesome. But if you take that to production, what are the things you have to consider? When you have millions of documents that you're going to be generating embedding for and querying that at runtime, what does the latency looks like? What if your vector database fell over? That is a single point of failure into your application. So how you think about making sure that you have observabilities, testing, A/B testing, and all that stuff for all these new components. I'm sure you have pipelines. If you're going to update those models or documents, if they change quickly, then you're going to have pipeline to quickly generate embeddings, updating your vector database. What is infrastructure you needed to ensure that pipelines operate successfully, efficiently, take least amount of time, right? If fail, who get notified? So if you're operating at scale again, how do you use infrastructure to really efficiently get that done quickly? Recently, I learned that now there are 3 different types of RAGs patterns. So I'm not sure how many of you know about this, from naive to advanced to modular. With advanced and modular, there are more components or more steps inside the RAG application now. So step back and think for a moment, how do I test those? How do I verify the request and response before and after each of those steps? How do I provide observabilities across those steps? Fine-tuning, right? Fine-tuning, some companies are leveraging open source LLMs and start doing fine-tuning, which is great. But from the perspective of operationalize them, you need compute resources. You need an easy way for various teams to do fine-tuning quickly, easily, without worrying about infrastructures. So as a platform team, how do you enable this and provide flexibility so they can try different algorithms or parameters in terms of fine-tuning, similar to model training in a sense. And they have the necessary access to GPUs whenever they need to fine-tuning. After you're done fine-tuning, you might serve that internally. So again, that comes back to model prediction similarly. But then there's different aspects that we talk about in terms of the right GPUs, machine types. The good thing is nowadays there's a lot of options out there that you can leverage vendors for this, provided that that is okay within your company's AI governance perspective of privacies and such. All right, and then a very hot topic right now, I think everybody kind of know, is about AI agents, right? They're supposed to help try automations for much more complex tasks. And a very interesting story that I heard from one of the videos that I watched recently from Eric Schmidt, the former Google CEO. So he said, yeah, agents gonna be great for us. But at some point, these agents gonna develop their own language and they start to communicate with each other. Scary, right? And then he said, when we reach that point, when we don't understand what these agents are doing, that's when we should pull the plugs. Anyway, so I thought it was a fun story to share. But step back, think about developing agents in the enterprise, right? Think about how do you test these? How do you do A/B testing? How do you understand what they're doing? Because they have tasks, they have decisions that they make, right? And they can communicate with each other. So there's a lot of non-deterministic nature in terms of how agent operates. So from the perspective of trying to understand and monitor and control what they're doing, that's going to be extremely difficult moving forward. So I don't even know how you operationalize these at this point. So we'll see. We'll see what's going to be like in the next 12 months. All right, let's talk about something a little more fun. Some of the use cases at DoorDash, how we leverage LLMs and such. The way I think about the kind of use cases that we have, it can be categorized into these buckets. The first one is augmenting classical ML, meaning speeding up the ML development process itself. The second one is leveraging the generative capabilities for some of the use cases, quite relevant for us. And then the third one is quite interesting, is leveraging the multimodal capabilities. So by the way, all these use cases are public, so you can go and actually search for them. Okay, first one about augmenting classical ML. The first one is about name entity recognition, essentially. At a high level, it's by extracting attribute value information from unstructured data, meaning the description of a food item or a grocery item. So like extracting the brand name from a grocery item, understanding the manufacturer, the brand, the parent brand, understanding the dietary attributes, right? Used to be that we have to train very specific model for some of these attributes, and that takes a lot of time. So now we can leverage LM to do this a lot quicker than before. And this helps in terms of building our catalog, essentially, our item catalog. So the more precise information we have about the products, then we can provide better personalized recommendations and such. The second one is also very interesting about query intent understanding, right? Very traditional kind of search-related use case, especially for long-tail queries. So classifying the query, what the user enters, we have a long list of tail queries. So the more we understand what those queries are, the better we at in terms of returning relevant result. And it used to be that there's a human in the loop in terms of looking at these queries, annotating them, and that is quite expensive, as well as subjective as well. So what's really cool is this by leveraging LMs for this, not only ultimately give better search result, but also improve the experiment velocity and iteration speed of these search-related models. So it's pretty cool. The next one is the generated capabilities. I'm sure you might have visited DoorDash or Uber Eats. You see like these menu items and images, right? Behind the scene, when we work with restaurants, some of them give us the menu information. They're not very clear and descriptive, or they might not have images at all. So leveraging the generative capabilities is very effective in terms of generating short yet descriptive description of a food item, right? Hopefully that will stimulate the senses. And then as you know, if you go to these DoorDash or Uber Eats and if a menu item doesn't have any pictures, very likely you're not going to order it. So have high quality image is very, very important to the engagement and conversions. And one day, who knows, maybe you can use this to translate all these menu items in different languages based on the user preferences. The third one is quite interesting and quite demanding from the perspective of the use case. You might have seen or read this article about voice ordering that DoorDash is building a product on. Apparently, there's a certain segment of DoorDash users would like or prefer to order food via phone, okay? And there's a lot of nuances in this use case. One is you want to transcribe from the user's voice to text and understanding all the nuances of what they are ordering, right? Imagine they want to order pizza, half cheese, half pepperoni, and all the nuances of the various options that customers can share. And so accuracy is extremely critical in that regard. And then finally, at the end, you want to share back in terms of the order information to the user. So you go from text back to voice. And because this is, the users on the phone, so latency is a very critical as well, right? You don't want to take 10, 15 seconds to come back to the user. They're probably going to hang up and order and go somewhere else. So this use case is very, very interesting from the perspective of performance and latency. And then, different Restaurants have different menus. So how do you then do that? Previously, the first iteration involved like we call prompt stuffing, essentially stuffing in the whole menu of those restaurants. That has limits. But anyway, so yeah, I think this is the team is still iterating on this. All right, let's get to the fun part. The practitioner perspective on this. I'm sure you have read many articles out there that talks about the emergence, LLMOps, emerging stacks, all the components. They provide a good blueprint for you already, which is great, which is a good starting point, right? But the question when you start thinking about building LLMOps in your company is, what do you start? Right? You have a blueprint, but what do you start? What principles should you use to decide where to start? Right? What factors should you consider when starting? And we can't just go and build all the components. We don't have unlimited resources. So where do you start? Okay? For us, right, it's a big question mark here. We have many teams within the company that want to leverage GenAI technology to build applications for their use cases. We have a diverse set of use cases, like some of those I will share with you. And nowadays, we have a lot of options in terms of vendor, which is good, but also a dilemma in itself. Right? Vendor solutions emerging and maturing from all the way from prompt management to fine-tuning, hosting, serving, all that good stuff. On the open source side, there's a lot of innovation at the same time that I'm sure you're following, like LangChain, Llama Index, LangFlow, Crew AI, and all that stuff like that. All right, you have all these. What do you do? What do you start, right? And I don't know about your team, but my team is still responsible for a large bulk of the classical ML workload that's making a lot of money for the company. We can't just drop that and go and do everything over here. Right? So you have to be really intentional and strategic in terms of where you want to start. So what do? We essentially go and try to understand what are the use cases within the company, talk to those folks to better understand what they're trying to do, what their journey is, where are they at? Are they at the beginning, the middle, or where are they at? What are the frictions, the pain point that they're facing? So this is helpful because this information will help us in terms of identifying the common needs and challenges. And it's a platform, I'm sure you know, that we want to build something that's common infrastructure that can be leveraged by multiple teams. And also, this is prioritization that I mentioned earlier will come in handy because by knowing which team has the highest priority project, then maybe you want to partner with those teams more closely than others. Okay? So that's what it means to be strategic. So we arrive at a set of goals here. They're not earth-shattering. They're just good old common senses, right? We want to help teams to be able to experiment because that's the name of the game at this point for most teams anyway. They want to experiment. And for the team that's a little bit of ahead, that they have V.05, now it's about iteration velocity. How can we help those teams to iterate quickly? What automation can we help with that? Cost management and attribution. This is a learned lesson from MLOps because when you start operating at scale, cost matters. But also in this new world, GPUs cost a lot of money. So you want to be able to track and attribute those costs upfront, right? So that's something that we got to think about, like how to help with that. And the last one I think is very, very important. It's which I call long-lasting. As you know, these models evolve rather quickly, new capabilities. So those are the pieces that are not going to be long-lasting in your GenAI application. So what infrastructure that you build today will still work, will still useful for the next 6 months to a year. Invest in that today, right? So for us, some of the things that we start doing is, for experimentation, is making LLMs accessible to the rest of the company. We're going to take on the front load work of actually negotiating vendors, identifying those vendors, and get them onboarded so other teams don't have to go and talk to those folks. So we do that on behalf of the company. It's a lot of work. There's a lot of security reviews and all that legal and compliance. But once we get that done, then that will help the rest of the team to be able to have access to the models. The gateway, surprisingly, plays a key role in the experimentation as well as iteration velocity. Many teams have expressed that I want to be able to easily test switching the model to understand if I get better performance or reduce latency, right? They want to be able to do it very easily so they can evaluate and iterate. As also the gateway helps with in terms of central logging of all the responses, request and response. You can apply, it's a centralized, so therefore you can apply a lot of security-related aspects into your GenAI applications. And cost management, because everything goes through that gateway, you can track the costs in a centralized place and attribute not only based on the team level, but it could potentially at the use case level if you do proper tagging, right? Logging tracing, I think is very, very critical. And then the next piece is evaluation. That's something that we're looking to do next. And I'll talk about that a little bit more. All right, so if you, in terms of observability and tracing, if you think about the various pieces in your RAG-based application, from the query to the retrieval, the context retrieval, right, to the response, and also to the user feedback. If you provide a centralized way for all applications to do this, that's going to help your team a lot in terms of understanding when things go wrong, how to debug problems. A lot of teams are doing this themselves right now to get started. But imagine if you have a centralized way to do that. It will be extremely valuable. Especially the user feedback one, right? Because anytime that somebody rolls out a new set of prompts and your business metrics start to go down, for example. Now, evaluation is, like I said, this is one of the things I believe is long-lasting. Because it doesn't matter what model you use. It doesn't matter what type of GenAI application you're building, prompt, RAG-based, whatever. You're going to need to evaluate, right, the performance of your applications, the accuracy, the latency, all that. So what we want to figure out is if there's a way in a declarative manner that team can build their evaluation set for their specific use case, and it just specifies some piece of metadata in terms of how to run, what they need to run, what metrics they care about. And then you have a framework or a service that will take that and able to run that at scale. Right? It will take care of all the infrastructure that needs to spin up, doing things in parallel, whatever that is, and then generate the evaluation metrics such that they're easy to query and understand. I believe this is a key part of the LLMOps, and that's going to be helpful, and it's going to be long-lasting as well. All right, a few more slides, and then we'll close it up. As you go from demos to production, the hierarchy of needs, you need to understand that for your company and your use cases. And it's not possible to prioritize all these all at once. So work with your team in terms of understanding which one are more critical and start with those. But at least understand what those priorities are for your company. All right, in my opinion, if you look at all those documentation or article about LLMOps, component improvements, etc., essentially you can think about these as various components in your LLMOps, essentially. So think about, okay, what you're going to start out with first, second, and third. And that was the goal. That was the exercise that I went through. Knowing that you're going to build these out over time incrementally. And over time, in my opinion, that these LLMOps and MLOps is going to converge into something called an AI platform that's going to support both classical as well as these LLM types of applications. So, all right, a few key takeaways here. We are at an inflection point, right? What that means is things are going to evolve rather rapidly, so keep that in mind. There's a unique set of challenges of these type of applications. Understand them well for your use cases and your company. Identify your goals and hierarchy of needs based on your company's specific environment, use cases. For now, focus less on infrastructure. I know it's common sense. Focus more on the long-lasting value components that you can start with. And as usual, it's a good playbook to go by. Crawl, walk, and then run. All right. Thanks everyone for attending. Hope you have the rest of a great conference.